Hi Year 13. This should now be your final lesson on the chapter on series. So you should now be okay with method of differences on exercise 2A. Then you just practice, I think, some repeated differentiation on 2B. Exercise 2C was introducing the basic Maclaurin series, and now we're going to look at combinations of functions and compound functions using the Maclaurin series. So I've just picked out 9A for us to have a go at. So we've got to somehow show that using the Maclaurin series we can convert 1 take away 3x times ln of 1 plus 2x into this infinite polynomial here. Okay, so you could start from scratch and use your Maclaurin series and build it up from here, but of course you are given quite a few basic Maclaurin series already on your formula booklet, and one of them is ln of 1 plus x. So you are allowed to use these. They may ask you to prove them. Let me just show you the ones that you're given. So you will be given e to the x ln of 1 plus x. We'll talk about the validity, remind me, at the end. Sine x, which we proved in a different video. Cos x, and you also get arc tan, so you get a few there, and then you will be able to, using these, use compound versions of that, you know, like sine 3x or e to the sine x, that sort of thing. Okay, so let's have a look how we just start this one off. So I don't do anything with 1 take 3x, so let's just write that out again. And this is my expansion for ln of 1 plus x. I've got ln of 1 plus 2x. So all we're going to be doing is a substitution. So wherever I see my x, I'm going to be replacing that with 2x. So 1 take 3x ln of 1 plus 2x is going to turn into 1 take away 3x. And then here all I'm doing then is replacing my x's with a 2x, because everything else is the same here, isn't it? So I'll just put brackets around them for now. So there's my first term. Here's my next term. Remember the brackets here so that you'll remember that you've got to square your 2 shortly. And then we're going to do 2x all cubed over 3. And I can do one more. I'm just checking how far we've got to go with this. We'll go up to 4 here. Take away 2x all to the 4 over 4. And I don't need to go any further because I only need to do the first few terms. Okay, so then I'll just neaten it up. I'll just leave the 1 take 3x for now. So let's just neaten this up. So this is 2x here. This is going to be 4x squared over 2. So take away 2x squared. This is going to be 8x cubed over 3. So plus 8/3 of x cubed, I suppose we could write. And here we've got 2 to the 4, which is 16 divided by 4. So take away 4x to the 4, etc. And then all we've got left to do is we've simply got to do 1 times by all of this, and then minus 3x lots of all of this. So I think I was saying in my notes in Google Classroom, sometimes they get messier before they sort of neaten up again. So I'm just going to do 1 lot of this, which of course is 2x, take 2x squared, add 8/3 x cubed, take 4x to the 4, and then I'm going to times all of that again by minus 3x. Bearing in mind I only need to go up to x to the 4. So minus 3x times 2x is minus 6x squared. Minus 3x times minus 2x squared will be positive 6x cubed. Then I'm doing minus 3x times 8/3 x cubed, so that will leave me with minus 8x cubed. I've gone wrong already, haven't I? That's going to be x to the 4 there, because it's x times by x cubed. And then can you see I don't need to bother doing that next one? Minus 3x times minus 4x to the 4. I'll have an x to the 5, and I don't need to do that further proof. So let's leave that there. And then all it is a matter of doing is neatening it up. So I've got only one term, a linear term, so there's my 2x. Then I've got minus 2x squared and a minus 6x squared. Shall I just start crossing these out like that? So there's my minus 8x squared. Then I've got 8/3 of x cubed add 18/3 of x cubed. So there's my 26/3 of x cubed. You get the idea. And there's my minus 4 x to the 4 minus 8 x to the 4. I think I've dealt with everything there, haven't I? So minus 12 x to the 4. Okay, so that's that first one. They may sometimes ask for the validity of that series. Well, normally you're given in the formula booklet that this series is only valid when x lies between 1 and negative 1. So all you need to do here is remember you're substituting x with 2x. So this expansion, this series is only valid when 2x lies between 1 and negative 1. So of course you'd say x lies between a half and negative a half. There's a couple earlier in the chapter where you've got to be careful on the validity. I think I remember it was question 1F. So have a look at how you do 1F. There's a clue in the question where you've got ln of 2 plus 3x and you have to worry about the validity. What we mean about the validity is it soon sort of spirals out of control and starts to diverge if x doesn't stay in this range, and then it won't be a very good approximation or conversion of this ln series. I think that's all you've got to do on 9A. I was just showing you this extra idea about validity.